it here to the end of day 2. I know there's a lot of places you could probably be, like happy hours or TSA pre-check lines or other fun stuff like that. So I will try to make this fun and engaging and worth sticking around for this long. So what are we going to be talking about here? If you look at the title, you're probably thinking, wow, that is a lot of CFP-friendly buzzwords all in one title. And you'd be correct. But most importantly, we're going to be talking about Firebase Remote Config. Along the way, we will also talk about Google Cloud Functions, some other GCP infrastructure, a few other fun tools as well. The Firebase Admin SDK is going to play a key role in all of this. And then just a pro tip, if you want your talk to sound more Android conference friendly, you have to throw with Kotlin in there. So of course, everything here will be written in Kotlin. That's just kind of a fun byproduct of it. Well, let's try this again. Bear with me, sorry. Hopefully that stays on. So yeah, just a byproduct of this. The fact that this Kotlin is not actually that interesting to all of this, but really, if anything, I like it to be an example of being able to use Kotlin to start to extend our skill set, particularly as mobile developers, into other domains. So this is something, particularly with my team, I've been trying to kind of push everybody to think of ourselves more as just developers as opposed to mobile specific. So hopefully this talk will show kind of a fun set of tools that we can sort of leverage our existing Kotlin knowledge to build interesting stuff with. And because I know it's the end of 2 days here, people might be a little bit fried by this point. People might have to leave early. I've left you a couple parting gifts here. If you just kind of want to mentally tune out a little bit or hang out, got a couple of resources here. The first one is a GitHub repo where I've got all of the samples here. So we're going to be walking through really 4 different examples of using sort of Firebase Admin SDK and Cloud Functions and such. And so you can find all of those in this repo if you want to just check those out later. And additionally, there's a blog post as the second resource here, which I wrote a couple months ago, which walks through in detail how to build out kind of the first couple examples. Hopefully we'll have another blog post or 2 coming soon about the second couple of examples. So if you just want to scan those, find those resources, also just share them, their most recent tweet on Twitter if you want to find them there. So why the need to scale remote config? One possible answer is that Nate just needed a topic to talk about, which again is totally valid, but I do like to at least root my talks in something a bit more pragmatic. So really all of this is stemming from actual problems that our team has faced over the last couple of years. And these are actual solutions to those problems, things that we either already currently have deployed and are using, or are things that I'm going to be trying to deploy and use in the background here in the coming days now that I figured out how to make them work ahead of the conference. So I want to go back in time a little bit, brace yourselves a little bit here. I want to go back in time to roughly springtime of 2020. There's a lot going on that time of year. I was working in a 90-degree closet at that point in time. And most pertinent to this talk, our team had not yet embraced feature flags for anything. And so with that had a couple interesting drawbacks. It meant that we had no data. Now, this could be no data in an analytics sense, which also would have been true at that point, but specifically here, I mean no data when we release a feature. We would release it, we have no idea whether it worked, whether it didn't work. There's no insight. We weren't A/B testing, we weren't experimenting at this point in time. We also were sort of living in this YOLO fire and forget world where we would generate our APK, hit publish in Google, and cross our fingers that everything was going to work, that the app wasn't going to crash. And inevitably, when we did find issues, somebody had to scramble, build a hotfix, push it out. We didn't have this ability to turn things on and off if we found issues with it. And lastly, and most frustrating to me when I joined the team, was that we didn't have the ability to sort of build new features in our main development branch. We were living in this world where any long-running feature lived in a feature branch until it was 100% ready for release. So this often meant that you had feature branches hanging out for a couple of weeks, maybe a month. Honest story, we had one feature branch that was already created when I started on this team, and it did not get merged until just about my 1-year anniversary. So generally, a feature branch living for about a year, that about once a month, someone would spend a couple of days to rebase and to update. Incredibly slow to merge, incredibly detrimental to our productivity. So as you can see here, early 2020 was very troubling times for our team. There we go. 2020 was very troubling times for our team for many reasons. So that led us to Firebase Remote Config. Really what we wanted was kind of an experimentation platform. We wanted this ability to change the behavior of our app without having to ship a new binary. And so Remote Config is one tool for this. It's the one that we chose. There's other tools out there. And so everything you'll hear in this talk, this is specific to Firebase, but the concept, the high-level thinking could apply to other platforms as well. If you're not familiar, Firebase Remote Config is just a cloud service that lets you change things in a dashboard somewhere or in a custom-built tool like we'll look at, and change the appearance and the behavior of your app. Really powerful. And so why did we go with Firebase? Well, it's really easy to set up. We were already using Firebase for Crashlytics at that point, so we already were kind of used to working in that dashboard. We didn't want to reinvent the wheel. We could have tried to build our own solution, as some organizations out there have done, but we're a relatively small team, so we didn't want to spend time in that. We already have a lot of infrastructure built on GCP, which backs Firebase. So again, that was very easy for us to integrate with and leverage the power of Google Cloud Platform. And then also Firebase really, it has the core functionality that we really needed at the most. It has parameters to let us provide values, and we have conditions that let us customize those values based on things like audiences and platform types and such. So it's a very easy choice for us. So we started to embrace this. We started piecemeal, as we often do with things when we're adopting new technologies. And so first up, we started it with just kind of the core testing and experimentation. So we were able to start using feature flags to sort of control whether something was visible or not, test whether that feature drove up certain metrics, and start to develop this culture of, like I said, experimentation, analysis, and sort of data-driven decision-making. So that was great. Next, we kind of realized, well, hey, we've got this feature flag now we're using for the experiment. If something goes wrong, we can simply turn it off, and boom, the experiment's over, but also the crash is over. So we were able to sort of circumvent some of those crashers that would have led to high crash rates and failure rates and ultimately unhappy contributors on our app. So that was great as well. We were able to sort of start to do better with monitoring and disable these issues before they became larger issues. And the last one, we kind of realized, hey, we've got this feature flag that we're sort of adding at the end of development. If we simply made that the first thing we did instead of the last thing we did, we can sort of develop in the mainline development branch. We'll keep it off. We'll maybe have it local only, so it never even propagates to sort of the cloud. And we can sort of solve this problem of these year-long feature branches or even these 2-week-long feature branches. So this one for me was my favorite win, because I don't like to wait to merge things. I want to get my code written, tested, reviewed, and merged and sort of move on to the next thing. So we started to solve all these problems, and really what we bought ourselves here was the ability to experiment, with greater stability, productivity. All of these are really great things. So, problem solved. I wish I could say the answer was yes. It'd be kind of funny if all we had to do to scale Firebase was use it, and we could all get out of here quicker. But no, not quite. All the problems were not quite solved. What we actually found was, over time, we ran into not technical issues per se, not really even a lot of engineering issues, but more operational complexity, kind of where the product and the engineering meet. And what we kind of found was that over time, as we used it more, as we introduced more parameters, more conditions, our number of sort of whoopsie moments started to increase slowly. And then over time started to increase more slowly. And what do I mean by a whoopsies here? Could be a number of things. Misspelled parameter names when we try to promote a parameter from dev to QA or QA to prod. So things don't work the way we expect. Could be things like a missing condition. Maybe you tested in QA with a condition that turns it on only for a certain region, and that condition is missing in prod, so it no longer works the way you expect. Could be things like accidentally changing a parameter type. You write it manually in Firebase Remote Config in your QA environment. You define it, let's say, as JSON, and you accidentally set it to just a raw string or a Boolean or a number when you promote it to prod. So again, that's likely going to break things. Or maybe my favorite was just the good old, why did that value change? Or its cousin, who changed that value? Maybe even also, when did this value change if you discover it after the fact? So there's a lot of things here that could go wrong and started to go wrong as you get more people working in these values, you start having more values, you start pulling in iOS as well into a shared project, so you have kind of doubling the number of values. And really all of these things at their core are risk. Things that cause us risk, that expose us to a poor experience for our contributors. And hopefully all of us as engineers, and especially as engineering leaders, we want to think about how we can reduce risk. And maybe even more so, reduce risk and also increase productivity. We want people to be able to move quickly, build meaningful features that solve problems, empower people to have all this flexibility, but also do it in a controlled, calm, safe fashion. And so that's really sort of where we arrive. We wanted to start asking some of these questions. How could we monitor for changes to these remote config values? How could we maybe validate changes? What happens if somebody changes a value to something that doesn't make sense sort of from a business logic perspective? And how could we sort of automate these promotions of one value from, let's say, dev to QA, QA to prod, and so on? How could we just sort of take the risk out of these processes? And so that basically led us to the question that we're going to explore in the rest of this talk, which is how do we build guardrails around remote config? And really the root of this, the core of this, is the Firebase Admin SDK. This is the tool that enables us to sort of build custom tools to solve our specific use cases for interacting with Firebase. So just a kind of a textbook definition here, Firebase Admin SDK is a set of server libraries that lets you interact with Firebase from privileged environments. Most of that probably makes perfect sense. Privileged environments maybe doesn't. Basically, this is a fancy way of saying you need to have authorization to hit the Firebase projects, which ultimately probably comes down to having a service account available with the remote config admin permission in our specific cases. This is something that likely your infrastructure team or somebody with enough GCP permissions can set up for you. So with this admin SDK in place, we're going to take a look at 4 examples here. The first one, we're going to look at how to build a tool that just gives us simple notifications when a remote config value changes. Trying to solve that problem of sort of who changed this, when did this change. Then we're going to look at a more complex version of that that gives us much more interesting and helpful formatted and diffed notifications. We'll look at a tool that lets you sort of validate changes to specific parameters and automatically roll them back if they're invalid. And finally, we'll look at a tool for automatically promoting values between environments using a custom CLI. So first off here, we have simple notifications. And I'm going to attempt to plug this in one more time, because I'm going to need my hands here. So yeah, let's look at this question of how do we know when something changes and who changed it? And so to kind of help show you where we're going, I want to actually show a demo first, talk about it, come back and show the demo again. So what we're going to do here is come into my Firebase projects here. So this is my own Firebase project backed by my GCP instance. And I'm going to come into this Uber training dev project, open up remote config, And at the moment here, we see I have one parameter defined. And so I'm just going to come in here, I'm going to edit this like one might do in their team in everyday work, and I'm going to change this to Chicago Robotic. I hit save, I publish, and we see I have a Slack notification now saying remote config changed to version 11 by my email address here. So this is it. Like, this is the most basic version, but this does at least move us towards answering some of those questions of why did this change, who changed it, etc. The version here basically represents the 11th time I've changed this. You can tell how many times I've been testing this out, prepping for the talk. But this is basically it. So this is very simple in terms of what you might get as like a developer or someone monitoring this channel. The infrastructure in place for this, though, is very interesting. We're going to walk through it in detail, and then we'll use all of that to build up to a more interesting example in the next step. So basically, the questions we need to think about answering then for this simple demo is, how do we respond to changes in remote config? How do we then extract the details about that change from sort of whatever change notification we do get? And then ultimately, how do we notify Slack in this case, or it could be whatever sort of source you want ultimately. So this is sort of a general kind of system diagram of what this looks like, of the system we're going to build up together here. So we change a remote config value that goes into sort of your remote config data store. That's going to ultimately trigger a GCP event that we respond to. That's going to call our cloud function that we're going to build and deploy. And then ultimately, we will notify Slack with that message that we saw of basically who changed it and what the new version is. So to help us sort of build a framework then for all the interesting things we're going to be working with here. Google Cloud Functions, if you're not familiar, is sort of Google's serverless execution environment for basically running code in the cloud. Basically, what we need to worry about as developers is we implement one interface, we override one method, and we deploy it, and Google manages all of the scaling up and scaling down for us. We can connect with other GCP services if we need to. We can respond to a whole host of different event types, as we'll see in a minute. But really, it's a great way for us to be able to write simple sort of one-off things, especially if we need to connect with lots of different existing services. So Cloud Functions work in a couple ways. One way is they can respond to basic HTTP requests. So if you need some type of very basic, let's say, backend service, but really it's like one endpoint or something, you might think about deploying this as a Cloud Function, depending on your expected usage and things like that. So basically, we get a request coming in, it's managed by the Cloud Function, ultimately routed off to our code, and we can do whatever we need to. Or we can respond to pub/sub events coming from GCP as well. And same thing, those will get routed to our function. Now we can write functions in a number of sort of runtime environments. Not all of these are available in both the HTTP fashion and the pub/sub fashion. This is kind of a superset of the two. But for our case, Java will work for the pub/sub version of Cloud Functions, which is what we need to leverage to respond to those remote config changes. And like I said, everything will be Kotlin. So again, it's a Java runtime, so we can use Kotlin there, no problem. And like I said, all we really need to do is to get started is to write a class that implements one of two interfaces, either raw background function, which will return to us sort of the message payload just as raw JSON, and we can do with that what we need to, or or background function, which takes a type. So if we wanted to create like a data class or something and have it sort of serialize that for us, we can do it that way. And then once we have that, we need to just override this accept method. So in this case, we're overriding raw background function, gives us the JSON, and then in that case, we could parse that into whatever we want and pull out the data. So we have started to see how we write this. Now we need to think about deployment. We can deploy locally from our machine. I'll show you what the command for that looks like shortly. You can deploy actually from GCP console itself. This is my least favorite option because I don't like deploying things from consoles. I want my configuration, my deployments to be in code where I can kind of see it and monitor more easily. Or you could build out deployment via CI/CD. This is my favorite option, but I did not build it out for any of these samples. So from a local machine, you can deploy using a command that looks something like this. And this looks a little bit overwhelming, so let's just kind of walk through this. So the key part here is this gcloud functions deploy. So this is going to use the gcloud CLI to deploy your function. The remote config Slack notification service mouthful there is basically the name of your cloud function in GCP once it's deployed. The entry point option here is then the name of the class, so that is the entry point that it should try to execute when it's trying to spin up your Docker container that contains this function. You can then specify the runtime, and this last bit here is just environment variable. So this is 100% custom to this specific implementation. If you built it in a way where you didn't have environment variables, you can totally skip that part. So this is just a way, in kind of my sample here, where we can easily configure this when we are deploying to different environments. So basically, I want to take a minute to get really deep in the weeds here. You don't care about the GCP infrastructure, just earmuffs for the next minute or so. But basically what happens when we run that deploy command, first off, it pushes our source code to a Google Cloud Storage bucket. From there, Cloud Build takes that code and builds that, and basically spits out a Docker container that it sends to artifact registry. So then when a trigger or an HTTP request comes that it recognizes, like, hey, we need to run this code, it'll basically spin up an instance of that container and route that request to it and run your code. Now, if you don't care about that, like I said, really all you need to think about is basically this. You run the deployment command, eventually you're gonna get your incoming requests, and in the middle is just sort of a black box of GCP magic. And depending on sort of where you're doing this, if you're deploying this in an organization that's already using GCP, you probably don't need to do much to get it set up. You very likely could run that command and everything will happen for you. If you're like me and you're building this for a set of demos and you have not set up everything in your GCP environment, you'll have to enable a few things like artifact registry, cloud function APIs and such, but it's fairly straightforward. So we talked about then that last bit there, getting the messages, those incoming messages. And I talked about the fact that we're going to be using this pub/sub sort of version of interacting with cloud functions. Basically, pub/sub is GCP's sort of event bus pipeline. It allows you to send messages from different components very, very efficiently and basically react to things to build scalable systems of sort of these separate components. So you can use pub/sub for custom topics that are very specific to an individual service or pipeline that you're building. There's also pre-existing service topics for things coming out of GCP itself. So a lot of the stuff you might interact with, like creating a service account, changing things in Firebase, have pre-existing topics that you can subscribe to. And then the last bit here is you need to subscribe to them. You have to have set something up that says, hey, I am interested in this, and then you can run your code. So in our case here, we are going to respond to this google.firebase.remoteconfig.update topic. And this is the thing that is going to route those changes to our function so we can respond to them. So we're going to come back to this deployment command. We need to just add one more thing here. We're going to add this trigger event. So we add trigger event, we give it the name, and this is what is going to tell that deployment to then respond to that specific event. If you had defined some custom topic somewhere, you could make a different cloud function respond to that topic by specifying that trigger event here instead of this particular one. And then just kind of the last quick tool here is for that last bit of notifying Slack. We can easily use the Slack SDK for Java. Not the most interesting part of this by any means, but just wanted to call it out there. And you could swap in whatever other SDK or tool you wanted to send messages to whatever makes sense for your team. So again, this is kind of the system we have here, where we've got changes going into remote config. We then have this GCP event, that Firebase update event being fired. That routes to our cloud function that we've implemented in Kotlin and previously deployed. We're going to pull the details out of that JSON payload and send that message to Slack. So let's take a look then at what that looks like in practice. So we already saw sort of what the event looks like when we actually get it into Slack. So let's look at some code here. So this is the code from the GitHub repo. We've got this remote config simple Slack notification service, and it's implementing this raw background function interface. We have a little bit of setup here just to pull out the configuration details. So this lets us deploy this to respond to different Slack channels if we want. We can change the Slack bot token if we need to change the way we're forwarding messages into that. Kind of beside the point here. Ultimately, the part we care about is this accept method. So again, I mentioned that we're getting this JSON response. So this is going to be a JSON response specific to that Firebase update topic coming from GCP. So in our case, we are going to just create a quick instance of JSON here and parse that into a data class that we created specifically for that event payload. So this is going to give us the update type, the origin, that version number that we're printing out to the console, and then ultimately the email address of whoever made the change. And that email basically corresponds to a named principal at GCP. So that could be a user, that could be a service account, but ultimately it's kind of the person or the credentials responsible for the change. So once we have that, in this case we're logging it out so we could see the details of this in GCP, mostly for my debugging purposes during development, but you might want it in a production system as well. And then in this case, all we're really doing is using our Slack client that we set up from the Slack SDK and notifying our Slack channel with this message. And so we see this was the message that we had printed out earlier when we changed that value. So that is really not a lot of code. Like this example is very, very simple. But with this, and with this understanding of how this is working end-to-end, there's actually a lot of interesting things we can start to build on top of this system. And so that's where we're going to go next. So the next thing I want to look at here are better formatted diffs, basically. Basically, we want to better answer this question, what exactly changed and what does that mean for us? Basically putting as much information about the change as we can into that Slack notification. And so again, we'll come back to this question of how do we build this? And so now we know how to respond to changes in remote config. We know how to extract at least some of the details, the new version of the set of values and who changed it. We don't yet know how to actually parse the specific changes though, or how to format them into something meaningful. But we do know how to notify Slack. So we're going to focus in on just this sort of third box here for this demo. To help with this, we're going to use Java Diff utils, which is a library that's really helpful for basically finding diffs between strings. So when we get back these changed remote config values and we basically have these sort of JSON blobs, we can use this to basically call out and format in a way that's very nicely rendered what specific values change. And we'll see what that actually looks like here in just a moment. To use the diff utils, we set up a diff row generator. The thing that's particularly interesting here is this old tag and new tag. You can use this to define any type of syntax highlighting or anything you want. So in our case, we will kind of highlight the old stuff with a strike through, and we'll make the new changes bold, which just, again, helps us visually parse that information. And then ultimately, we can kind of pass two strings. So in this case, we take a JSON of like the old value and a JSON of the new value, and this will sort of generate an output string that helps us differentiate what those changes look like. So this is what kind of the new system is going to be. Again, looks very similar to the last one, except that this time within our cloud function, we're actually going to load the sort of fully populated set of parameters and conditions from remote config, diff the changes, and then send that on to Slack. And so let's take a look at what that looks like. I'm going to go into a different environment here where I have this specific one deployed. And let's make a few changes here. So let's add a parameter. We'll just say new param, and default value will just be Roboto. Let's delete this old one that I had here. And let's update this one, say some description. So we've got a deletion, an addition, and an update. And we'll go ahead and publish this. And so this time we're actually going to go to a different Slack channel because this was deployed to a different channel using different credentials and stuff. But this time we get an output that has a whole lot more going on in it. So we see specifically here, we're breaking this down between things that were removed, updated, and added. So again, very quickly, we can start to visually understand what's going on. And then we get this formatting. So we get the strike through on the parameter that was removed because everything was changed. On the added section, everything is bolded because it's all new. And then in particular, in the updated section, we see it's hard to see in sort of dark mode it's like here, but the description which was added, which was also bolded. And if we actually then come back here and let's change that description one more time, call this just some other description, and we publish. This time, oh, actually that is not rendering how it should be. What should be getting rendered here is some description should have a strike through it. That's how it renders in the version of this that we have deployed at work. Not sure why it's doing that here. I must have messed up something in that formatter. But the idea here is to basically clearly distinguish between what was changed and what was added. So in this case, we still can see something was updated here, and we can kind of visually do that diff. Having the formatted version makes it a little bit better. But still, this is actually a nice step forward for us. This has really helped us be able to understand sort of what was changed, what specific parts of it was changed. Was it just the description or was it the actual value? This has really helped us understand better what's going on in our remote config. So let's look briefly here at the code for this one. So we will close out of the simple example and we will pull up the next one. So this one, again, is working out of really the same shell. We still have a raw background function. We are still implementing, we're still implementing raw background function. We're still overriding the except here. And we're still parsing out the messages coming from GCP. What we're doing with that, though, now is where it gets interesting. So this is where we're finally using the Firebase Admin SDK. So what we're doing here is fetching the new config value. So when we get that message that says, hey, something changed, we get a version. It might be, let's say, version 10, whatever the current version is. So we are fetching the template, which is effectively the set of values and conditions for version 10. And then we also get the previous config. So we just pass version -1. The reason we get both is because we want to build up this diff. We want to know specifically what is in the new one that's not in the old one and vice versa. So we get both of these. Once those are both loaded, we pass them on to some custom code here that ultimately is going to return to us a diff of parameters and a diff of conditions. So we have this diff collection object here, which is something that we created, just a data class with a couple of properties on here designed for just holding these things so that we can access them later when we want to format or output a message. So this construct diff basically is just doing kind of some set operations here to build up a set of these things and checking what is in one set and not the other, basically determine what was added, what was removed, and then what things are present in both, but just different, what was updated. So we're not going to go through all of this because it's not necessarily the focus of this. You can check it out on GitHub. But ultimately, we return back this diff collection, which again tells us these are the things that changed, these are the things that added, removed, etc. And so now we want to generate this useful output message. So we create this diff formatter, which is where we're using this diff util class. Again, we set up this generator here, where I think I might need double tilde here. We'll see, figure it out later. But basically, we just go through these parameters and we use string builders here to sort of put the highlights of the header, some of the just metadata about the change. And then ultimately here, we sort of get the markdown formatted message for the conditions and for the parameters separately. So we know if you changed either of those things. So if we just come into this, again, we process the removed, the added, and updated separately. And ultimately, the magic here, the part that's actually interesting in all of this, is that we use that diff util generator that we set up to basically spit out these formatted strings that highlight those changes. And so we basically give it the sort of original value that we're currently evaluating, the updated one, we sort of stringify that, and we pass it to this diff generator, and then it will determine, all right, which things were added, which were removed. It'll perform that syntax highlighting that we want. And then ultimately, we just get back a bunch of strings that have this formatting attached to them, and we send that off to Slack. So we get the diff, we turn it into the markdown formatted string, like we saw here, and then we pass it to our Slack notify client, just the way we did before. So again, nothing too wild here. The really interesting bits is that we can fetch a specific set of values from a remote config using the Admin SDK and giving it a specific version. And then everything else from that is really just up to us. It's figuring out how we want to calculate what changed, how we want to format it. And so in our case, this worked. This has helped us. You might want to format it in a different way, maybe more simple, maybe more complicated. But once you get those set of parameters and conditions, the world is your oyster. You can do whatever you want with it. So that kind of wraps up the second demo. So now we've got the very simple notification. We've got the more interesting complex notification. So this is where we've been for a while now on our team. But the next step of this has always sort of been, well, what if we could sort of add validation to some of these values? We wish this was something Firebase just allowed us to do in the console. Sort of say, like, hey, here's a number maybe representing a blurry image threshold for some algorithm we've implemented. And let's say this is the range of acceptable values and reject anything outside of that. That's kind of what we want. It doesn't exist, but we can build it. So that's what we're going to kind of look at now. How could we build something that protects us from these types of invalid changes? Still gives us the freedom to change values on the fly, but builds guardrails in so we don't do something like change a Boolean type to a JSON type, or we don't set some URL that is completely bogus or something instead of going to like your terms and conditions or something like that. And so again, this is actually fairly straightforward in terms of pure concept. We can get an instance to a remote config instance using the Admin SDK again. And there's a rollback method. There's not a whole lot to this. We just need to tell it what version to roll back to. So again, this time we're going to have a system. Again, we're using the same basic structure for this one. But this time, once we get that loaded set of parameters, we're going to write some custom validation. We're going to have basically a map of keys that we care about and validation functions. And in this implementation, we'll simply check, are all the keys valid? And if they are, we'll go ahead and let that change go through. If they're not, we'll notify, hey, some of these things weren't valid, we're going to roll this back. In the future, before we actually productionize this, we'll probably extend this to reject maybe just the invalid ones and let the others through. But in this basic example, we're just going to reject everything. So again, demo time. Pull this up. So this time, we've got this parameter value here called blurry image threshold. And this is really kind of an actual use case for us. We do have an algorithm that helps us determine if images that our contributors are taking are blurry or not, so that they get that feedback up front, as opposed to maybe having their task rejected down the line and missing out on earning money for that task. And so for us, I think our valid set of ranges is something like, I don't know, 4 to 7 or 4 to 9. I don't know why it's that set of values, but that's kind of the set of values that we have found to actually be meaningful. Anything outside of that, and the system just starts to break down. So here we have a similar type of thing. What we're going to see here is I'm going to try to change this to 10, which is outside of the acceptable range I've defined in the cloud function of 0 to 5. So I'm going to publish this, and we'll come back to Slack here. And so what we saw here was actually several messages all in a row. So we saw this message right here saying, actually first we saw this one. So we saw the change from 2.5 to 10. And this is what I was trying to show before. See, in this one, it's actually striking through the old value, and the new value of 10 here is bold. I must have implemented it wrong in one, but not the other. So we've got the new value, but then our new function kicks in here, and it says, invalid remote config changes were published. The changes have been rolled back. We then see another message printed. The first function then triggers again because that same update event was triggered. And this time we now see this going back from 10 to 2.5. So we see it reverting that value. And if we then come back here into Firebase, if I refresh this, we see that I'm back at my good known state of 2.5. So we made the change here. Both of our cloud functions then operated sort of together to ultimately detect, hey, this is no longer good, this is going to mess things up, and immediately roll that back. So in theory, could this value have made it to a user? Maybe in the few milliseconds that it was there, but in practice, no, this is going to protect you from sort of those bad configs that you might not otherwise catch in time. So again, let's take a look at the code here quickly. I know I'm getting low on time. There we go, automated rollback. So one more time here, we're working out of the same basic shell. Come to our accept function here, and we're going to get the version that was just changed. We're going to load the template. We're going to load the set of values for that version. And then the magic is happening really right here. We basically iterate over all of the parameters in this case, and we map that into a true or false. And basically whether it's true or false comes down to this validated parameters map. So for the average parameter, it's just going to be true. For the things we actually care about, though, we have defined this map here. So we have a key, and we have a function. So in this case, we're validating this blurry image threshold. We're doing a few different things here. So we can validate that the type is in fact number. And so if we change this to JSON, this would return false. It would roll that change back. We can also then here validate that it is an explicitly defined parameter. So if somebody tried to remove this or just set it back to app default, that could revert it as well. And then finally, we basically check, is it in this acceptable range or not? So in this implementation, this is very straightforward. There's no magic here. If we were going to start doing this with lots of parameters, we maybe want to think of a little bit better way of defining a bunch of parameters at once. But for us, we really only have a small number of things that we care about in this kind of way. So something like this actually would scale fine for us for a while. Maybe a year from now, we'll be doing another talk of how we scale this solution. We don't know. But basically, this lets us put those guardrails around some of those most important values. So ultimately, we map all those things into true or false. We basically reduce that into a single, like everything was good, or no, we need to roll this back. And if the changes are not valid, we call rollback with version -1 again. And that's it for this one. So again, the basic structure here of the system is empowering us to do a lot with not a whole lot of code here. And for one last demo here, we're going to sort of move past the cloud function infrastructure here And now we're going to think a little bit more locally to our machine. So now we want to solve this problem of, all right, I have my parameter working in QA. It's set up perfectly, my conditions, my values, everything is great. Now I need to put that into prod. And the way we do that today is that someone manually copies it over. And we have run into issues where people do not copy it over correctly and things break and you don't know why they break. So this is sort of the last thing we're looking to solve in this set is how can we basically take the user or take the developer out of that and just automate that. And we're going to do that in this case using Clicked, which is basically a library for Kotlin that allows you to build CLI tools. And so we're going to build a CLI to basically take in the parameters we want to upgrade, specify the sort of the to or the from project and the to project, and then it will promote those values automatically for us. So to do this publishing, again, not too difficult with the admin SDK. We get our instance of remote config. We load the current template. We then use that template as the baseline to add things to it. So we might add 2 or 3 custom parameters to it. And then ultimately, once we're satisfied with the new template, we call publish template and we pass it in. So again, there's not a whole lot here really conceptually. The kind of system for diagram for this one looks less like this. We invoke the CLI. We pass the parameters into it. We parse those out. We load up the 2 templates from the admin SDK. And then we do a quick validation just to make sure that the parameters we specified actually exist in sort of, let's say, dev before we try to promote them to prod, we'll say. If they do, then we'll go ahead and add those to the template and publish it. If they don't, we'll just send a message and move on with our day. So for our kind of last demo here, let me come into remote config. I'm going to come back to my training project. And notice here, again, we have current conference name as a parameter here in training dev. Go back to training, we have no current conference name. So now I'm going to pull up in my terminal here, and I'm going to invoke the CLI tool that I had sort of previously built and added to my path here. And I'm going to pass in current conference name as my parameter. It's going to then ask me which from project. So in this case, it's in Gubar training dev to Gubar training. So now it's going to load that set of values, and then it's going to say, okay, let me make this slightly smaller so we can read it. Oh, that didn't help. Basically, it's saying we're loading this. We actually found that parameter in the from environment. It does exist, and basically we're staging it. Like, look, this is ready to go. Are you sure you want to promote this? In this case, we'll hit yes, and it says published value. So now we come back here. I hit refresh, and there we have it. It automatically pulled the parameter over for us with everything associated with that. I'll put an asterisk next to that. If you happen to look at the code, this will not pull over a condition. So for example, let's say I had a condition in dev that said make this Roboto if you're on Android and make this iDev if you're on iOS. If I tried to promote this, it would fail because that condition doesn't exist. So again, before we fully productionize this for our team, we'll add in a bit to check the conditions as well. But that's kind of a trivial derivation of what we already have there. So to just kind of round this out then, let's take a look at the code for this one. So like I mentioned, this is using Clicked, which is this library for building CLIs in Kotlin. So basically we extend this clicked command here. We can define our from and to options here, and we can actually pare this down to a set of known environments. You might have a specific set of development environments and one specific prod environment, so you could limit that, you can make it open, whatever is useful for your use case. And then we parse out any of those arguments, so in our case, the remote config parameter names, and then we override run. And so in our case here, again, run is going to use the admin SDK once again to load up the sets of values. We then check that those parameters are actually there. So we parse things out of the current template. If they are in fact there, we call this confirmation. So this is where we basically tell the user, hey, none of these exist. We're not going to promote anything and terminate. Or we'll say X number of parameters are ready. And we'll actually call this confirm method, which comes from the library that will require me to actually say yes or no, do we want to proceed or not. And basically, once we have confirmed that we want to proceed, we add the parameters that we took from the from environment. We add them to the template from the new environment, which really all that is basically adding those parameter types into this map. And then ultimately we call publish template with that sort of updated set of values. So again, we basically are using clicked here to build a little shell to allow us to configure some things. We could hard code that and make this even more simple if we wanted to. And then we basically take in those strings, we validate that they actually exist in the template, we add them to the new one, and publish it. And so yeah, that's it for the set of samples. So again, just kind of in summary here, if you want to extend what you're doing with Firebase Remote Config, and you're frustrated with the options available to you in the default console, the Firebase Admin SDK is sort of that silver bullet to extend the functionality for you. And you can integrate that into whatever sort of set of tools you want. You really just need some way of executing that. So whether that's cloud functions, a CLI script, just some standalone executable that you run as a one-off whenever you need. The key thing is you just need something to run that admin SDK. And again, we saw that it doesn't have to be Kotlin or Java. There's other runtime environments as well if you have a language of choice. But really here, the interesting concepts is thinking about what are the pain points with remote config, building tools around that, and then, in our case, notification was a big part of it, letting people know when things change, when things were rolled back. But again, once you have that admin SDK, you can build whatever you want with it, which is really powerful, and it really has helped us in the way we manage these things. It's helped us be more creative in how we group them in the console, how we separate them out. It has actually had a positive impact on us. So again, if you want to look at the resources, all the GitHub samples that we walked through are here, the blog post. There will hopefully be more blog posts coming soon. And yeah, that's it. Thank you.